Nuclear power plant is now in space. Nuclear power and related technologies promise to make interplanetary missions faster, more efficient, and cost-effective, ushering in a new era of space travel to Mars, our solar system, and beyond. Countries all over the world are trying new technologies to acquire more access, stability, and influence beyond Earth, as space becomes the next arena of domination. And now, the Defense Innovation Unit of the U.S. government has devised a new strategy to test and deploy nuclear power systems in space by 2027. So, what are they planning? And what are the benefits? Stay tuned, as in today's video we will take a look at the nuclear power plant. The Defense Innovation Unit, a Department of Defense unit, is solely dedicated to launching and growing commercial technologies across the U.S. military at commercial speeds. Compact fusion and next-generation radioisotope concepts are now being tested on the ground and in space by the group. On May 17, the organization announced 2 prototype contracts to demonstrate the next generation of nuclear propulsion and spacecraft power capability. The ultimate goal is to demonstrate orbital flight in 2027. Ultra-safe Nuclear and Avalanche Energy were awarded contracts to showcase the next generation of nuclear propulsion and power capability for spacecraft. These companies will test technology that will allow small spacecraft to maneuver in cis-lunar space at will, allowing high-power payloads to be carried on space missions. The ultra-safe Nuclear and Avalanche Energy. The ultra-safe nuclear pilot will show how a charged, enclosed nuclear radioisotope battery, dubbed Ember Core, can be used in space for propulsion and power. When compared to plutonium systems, it will be able to scale to 10 times greater power levels and provide more than 1 million kilowatt-hours of energy from just a few kilograms of fuel. Meanwhile, Avalanche Energy's Orbitron aims to trap fusion ions in electrostatic fields, using a magnetron to hold electrons closer to their nuclei, atom cores, than is typically achievable. The fusion burn that results produces energetic particles that can power a high-efficiency propulsion system by generating heat or energy. Orbitron devices, in comparison to other fusion concepts, are promising for space applications since they can be reduced in size and used as both a propulsion and a power source. Keeping in mind that future space missions will require more electrical power to improve spacecraft capabilities for orbital adjustment, material transfer between space shuttles, and other tasks. While advanced nuclear technologies will provide the speed, power, and responsiveness needed to keep a competitive edge in space, nuclear technology has historically been developed and operated by the government, but they discovered a robust ecosystem of commercial enterprises, including startups, who are innovating in space nuclear power. The Defense Advanced Research Projects Agency. Apart from DIU, the Defense Advanced Research Projects Agency is another military body looking for cis-lunar nuclear technology. The company declared on May 4 that it is ready to move forward with a project to design, manufacture, and assemble a nuclear thermal rocket engine, with a flying demonstration in Earth orbit scheduled by 2026. DARPA's Demonstration Rocket for Agile Cis-Lunar Operations program, which intends to create a nuclear thermal propulsion (NTP) system for use in Earth-Moon orbit, will benefit from the concepts. NTP generates thrust by heating hydrogen or other propellants in fission reactors and shooting them out of nozzles, resulting in a thrust-to-weight ratio 10,000 times higher than electric propulsion systems. DARPA officials said in a summary of the Draco program that it outperforms chemical rockets because the propulsion efficiency, specific impulse, of NTPs is 2 to 5 times higher. NTPs are also being investigated by NASA. These devices might get men to Mars in half the time it takes today's propulsion systems, which would take 6 to 9 months. NASA's budget request for fiscal 2023, which has yet to be approved by Congress, includes $15 million for nuclear propulsion, and NASA is also involved in the Draco project. Surprisingly, NASA and the Defense Advanced Research Projects Agency, DARPA, in addition to the Department of Defense, are working to adapt nuclear fission methods for larger spacecraft. Future missions will require increased maneuverability and electrical power to enhance spacecraft capabilities, such as orbital modifications, methods to control or simplified orbiting, material transfer between orbits, and solar shadow operations, to mention a few. As a result, DIU anticipates its NAPP initiative to have a direct impact on how the United States uses space power. And that's all for today's video. What are your thoughts about nuclear power in space? Are NASA, as well as the Defense Advanced Research Projects Agency, doing their best? And will a project be possible? Let us know in the comment section below, and go through the channel for more videos like this. Thank you so much for watching. Until next time.